this video tutorial, I'll be going through translation. Now, this is a topic that you will need to pay very close attention to, as it involves some amount of calculations. However, at the same time, you can actually use your basic understanding of the number line to actually solve these questions. So I'm going to read, and of course you just follow. In mathematics, the term transformation refers to some kind of change in relation to geometry. It is usually a movement of a plane figure from one position to another. So that right there tells you that we're dealing with movement of objects. In this case, we're looking at movement of two-dimensional figures. Now, the types of transformation include translation, reflection, rotation, enlargement, shear, stretch. And for this, you'll be looking at translation, reflection, and rotation. So we're looking primarily now at translation. So translation in mathematics means a glide or a shift of an object from one point to another. For example, the sliding of a book across a table, the pushing of a desk across the floor, etc. So just take a moment to just understand what is just being said to you right now. You're gliding something, you're moving one object from one location to the other. So if you move something from point A to point B, then there is generally no change in how it actually is shaped. For example, when you move from home to school, you are still the same person. And that concept is very important when it comes to understanding what a translation is about. So moving on, a translation is a movement along a straight line in a fixed direction without turning. Again, a translation is a movement along a straight line in a fixed direction without any turning. It can be described informally as a glide or a slide. When an object undergoes a translation, all points on the object undergoes a translation. All points on the object move the same distance and the same direction. Now, I know that's a lot for you to actually process, so I'm going to get right into what it means. So all of the fanciness that you've actually been reading is what I'll be demonstrating to you very shortly. So looking at what we actually have here, we have A prime is equal to B prime, which is equal to C prime. And this is equal to 4, 3. So I'm going to go to the bottom here. This 4, 3 is called a column vector. It's a unit that you'll be making use of to solve for translations. Now take note, this is just one example. Column vectors can take the form of any number that you can be given, or in some cases you will have to solve for. So continuing from where I left off here, now to understand, 4 is the distance moved or parallel to the x-axis in a position direction, and 3 is the distance moved parallel to the y-axis in a position direction. In a positive direction, In this notation, the number gives the movement along the x-axis, and the bottom gives the movement along the y-axis. So in general, any translation can be described as xy. So most of you, of course, are understanding of when you have a point, it's written as xy. However, when you actually have to deal with these column vectors, you'd have x on top, y at the bottom. Please take note, there is no division sign. A lot of students make that mistake. It's not a division sign, it's x on top, y at the bottom. So I'll be explaining this concept here now. So I have a online software called Desmos, and I've entered the points that you actually would be making use of. So A is -3, 0, B is -3, -2, C is -1, -2. And here you see the triangle. Now the translation that you're working with is 4, 3. And in that understanding, what you simply do is you move along those positions. When I say move along those positions, you're going to be moving 4 on the x-axis and then 3 on the y-axis. So, with that being said, 4 on the x, 1, 2, 3, 4, and now 3 on the y, 1, 2. I'll have to zoom out now. Actually, let me bring this back out so it's easier. Zoom back in. So that's 1, 2, and 3. Don't pay attention to anything that's happening there. Just watch what I'm actually doing. So this is 1, 2, 3, 4. 1, 2, and 3. And then finally, 1, 2, 3, 4, 1, 2, 3. So if you look at these two triangles, here I have them in this shade of blue and this one in the shade of pink, you notice that they are very, very similar to one another. Now, something for you to actually understand. Yes, something for you to actually understand. The value of your translation determines how you move. Now, I moved, if you notice, to the right and then up. The reason being is because of my x value that I'm working with is +4 and the y is +3, which means I'm moving in the positive direction. As I actually go through some problems that I'll be solving, you'll see exactly why it is that way. So if you actually look here, you start at -3 and then -3, 0, and now you're at 1, 3. Then B, when you move across, you're at 1, 1. And now C, when you move across, you're at 3, 1. Now that should be a hint to you that there's a way for you to actually solve these questions, which is what I'll be moving into now. So the instruction given is determine the image under translation using the common vector T, X, Y by calculation. So what I'm about to show you is what you can do, or what probably I'm going to say what you should do, is have object plus translation equals the image. So in looking at that, let's look right here. You can call this our object. We did our translation, and now we have our image. So let's look at the very first question that we actually have here. It says that P is 3 minus 1, and the translation is -2 minus 3. So P is what we're given, and P is equal to, just a moment please. Yes, P is equal to 3 minus 1, and our translation is equal to, so I'm going to write it like this, -2 minus 3. So this is where you need to actually understand something. P, or any letter that's by itself, is the object. T is your translation. The image will be written P with a small one, or P prime. That's what you actually have to solve for. So with that being said, I'm going to write it now as object plus translation equals to my image. My object, which I'm going to write here, plus my translation, which I'm going to write here as -2 minus 3, is equal to the image that I will be solving for. Now, as I said before, the x goes on top, y goes at the bottom, and of course you maintain their signs. So writing this now, what I have is 3 plus, and I'll put in bracket, -2, So that's my top, and now for my bottom, it's minus 1 plus a minus 3. Now, like I've told you before, you should be making use of your calculators to actually start working so you become comfortable with it. So this is equal to 3 minus 2 and minus 1 minus 3. Now I'm doing this for persons that don't have a calculator, but I'm going to take it that you're now going to pause this video, go and get a calculator or probably use your phone, and you're going to follow through. So 3 take 2 is going to be 1, and minus 1 minus 3 is going to give me a minus 4. Now take note, this is a column vector, and what you're solving for is a coordinate. So your final answer should be P prime is equal to what's on top is your x, comma, what's on the bottom is your y. And that's it. So that there is example 1. We have a few more to actually go. Now in example 2, so I'm going to start taking the information out here. A is equal to 3, 2. It undergoes a translation T, and then it tells us that A is mapped onto A prime. And the image of A, which is A prime, is given as 7, 3. Which means it wants us to describe the translation 2 using a column vector. So we're solving for T. So again, that's one simple way that you can actually approach these questions. You take out the information that you're actually given so you understand what you need to actually do next. So going by what I actually showed you earlier on, my object plus my translation equals my image. Good. So I'm going to go back and forth here now. My object is A, and of course I'm writing it in column vector form, and A is given as 3 on top, 2 at the bottom because of the xy components, plus my translation, which I do not know, is equal to the image, which is, so let's look at the image that we have. It is 7, 3. So the image being 7, 3, it will be 7 on top, 3 at the bottom. So my T is equal to my image, 7, 3. Now this, as we would say, is going to go over. Since it's adding, it's going to go over and it's going to subtract, giving me 3, 2 still. So this is equal to 7 minus 3 and 3 minus 2. So 7 take 3, so translation, 7 take 3 is 4, 3 take 2, 1. And you see this is in column vector, so a translation, since it's in column vector, means that you leave your answer like this. Good. So I know they actually gave you it here, but pay no attention to this. Keep your column vectors the way that you actually do to avoid you being confused in the future. All right, so what's next? All right, so we're told a point A. So a point A is equal to something. It's mapped onto A prime, which we're given as 2, 3. And our translation is equal to vector form minus 1, 4. So in this instance, what we're actually going to be solving for is the object. So I'm just going to write all of that here now. The A equals to what we're going to solve for. The translation is equal to minus 1, 4. And the image is equal to 2, 3. Now this is our information, and we know that the object plus the translation is equal to the image. Our object is A, that's what we're solving for, plus our translation, which is minus 1, 4, is equal to the image of 2, 3. So as we say, this is going to go over. A is equal to 2, 3. Since it's adding, it's going to come here and subtract, and minus 1, 4. Please take note, I did not change the signs. I wrote back everything that's in that bracket. So A is equal to 2 minus 1, and we have 3 minus 4. So this is equal to, using your calculator, you'll enter 2 minus, open bracket, minus 1, close bracket, equal, and that would give you 3. Then you have now 3 subtract 4, which is going to be minus 1. Now, since we just solved for an object, which is a coordinate, A is going to be equal to, what's on top is x, what's on the bottom is minus 1. Good. Now, this one here, I'll need to just switch between some colors for you to explain this particular concept. Now, in some questions, you'll be given a drawing like this. So I'm going to be zooming in a little bit more, place more emphasis on what we'll be doing. So, with this being said, we are actually trying to understand what the vector is. Now, to solve this, you only need 1 point. So what I'm about to do is this here, let me just confirm, ABC and ABC. So this here is my object O. This is my image. So what I would normally do is to draw some lines going across and going up based on whatever question you're actually given. Now this is important because of 2 reasons. You're going to count how many positions you actually move to understand exactly if it's positive or negative. So direction is also very important. So let me just do this once more. Alright, there's a lot of lines there. How about I just use B so that you can actually see it more clearly, ignoring all of the other stuff. So I'm going to use 2 colors for this. I'm going to go orange here, since I already wrote in red. So if I decide that I'm going to go B, it's the same issue. I'm trying to find a way where you can actually see everything very clearly. Alright, actually I'm going to stick with A. So I'm going to use orange to go across there, and I am going to use this green, and I'm going to use that to just go up. Good. Now, let's say our starting point is here. So starting point here, we're going to be moving across. Moving across means you're solving for x. So we're solving for an x value. Now if you remember your number line, you have 0, then you'd have 1, 2, and then you have minus 1, minus 2. So moving to your right means you'll be moving positive, so you have 1, 2, 3, 4. So I move 4, positive 4, I'm just going to put a plus so persons could follow me, positive 4, which means that I move to the right, and now I need to see how much I moved down. So starting point here, 1, 2, 3, 4, 5. Good. So y is equal to 5. Now which direction did you actually go? So let's do up a quick Cartesian plane here. This is 0. This is my x-axis. This is my y-axis. So here is going to be 1, and here is going to be minus 1. Going up, this is positive 1. Going down, this is minus 1. So use some arrows to indicate direction. So since we moved downwards, this automatically tells all of us that we moved in the negative direction. So the translation is 4 minus 5. And that's it. So again, you could choose any position that you actually want, and you could make use of this to actually solve it. Now, if the reason why I wanted to use B is because if I used B, you'd have seen it more clearly at the top. But then if you look at the bottom here, I'd run into a little bit of a situation with the pink. So I just stuck to A. So again, it's up to you how you actually want to solve it. Now this question here actually has one flaw. So if anyone actually solved it, I'm going to just point it out to you right now. Now going by everything that I actually spoke of so far, it tells you how to move. And this 7 here, how they had it, which is 7 minus 3, told you to move 7 positive x and minus on the y. But then you look here, that's not what you actually see. Now when you read what's here, it says this figure slides 7 units to the left and 3 units down. So it should be moving to the left and down. By simply changing the sign in front here from positive to a negative, it solves that problem. So to show you what I'm actually talking about, I won't be solving all of the questions. I'll just be showing you what actually happens here on this graph. So having 2, 4 plus minus 7 minus 3. So I have an object, I have my translation, I'm solving for my image. It's going to mean I have 2 plus a minus 7 and 4 plus a minus 3. I'm putting these in brackets. Now this is equal to 2 minus 7 is going to be minus 5, and 4 take 3 is 1. So this is actually 3, this is minus 4, this is minus 5. So minus 3 minus 4 minus 5, and here is 1. And if you actually complete doing the process for the other questions, you would actually arrive at the same answer. So I want you to actually try this question out, you work it out, and if you don't have your drawing looking like this, then it would tell you that you need to actually just contact me and we could discuss it. So this is going to be the first of many lessons that we'll be going through for reflection. So you should have, if not a graph book, you have the checkered line books that the school provides to you. Have one of those on hand, and you will be practicing all of these questions. And as per usual, for the end of the week, you know exactly I'll be putting the questions in the Google Classroom, and you'll actually have to put your answer that you got there. So with that being said, I'll now be bringing this video to a close. I hope it has found you well, and do enjoy the rest of your day.